Hello, so now let's look at some slightly harder solving equations examples. For example, this thing here, this looks absolutely dreadful, like it's horrible. So what I need to do is I need to make it look like something that I've seen before. So what's making this thing awkward? Are you happy it's the fractions? So I need to try and get rid of the fractions. Now the easiest way of doing this is by getting it all the left-hand side over the same fraction. So let's think about this. We've already looked at this. I want a common denominator. I'm going to use 6. So I'm going to put this thing over 6. And I'm going to add it to this thing over 6. And the right-hand side I'm just going to leave alone for the time being. Now let's think. What have I multiplied that first fraction by in order to get a 6 on the denominator? I must have multiplied it by 2. But just be careful, I need to multiply the entire numerator by 2. So you might be able to do this in your head now, but I'm just going to write it as 2x plus 1. Remember to put it in brackets because it's the entire of x plus 1 multiplied by 2. Then have a look at this thing. Well, I have the x minus 4 over 2, and that's changed to a denominator of 6. So what have I multiplied by? Well, I've multiplied by 3, haven't I? So I need to multiply the entire numerator by 3. Like so. Okay. Then I can put all of this over the same denominator. So it's all over 6. And on the left-hand side, well, can you expand the brackets out with me? So 2 multiplied by x plus 1. That's going to give me 2x plus 2 because the 2 visits everything inside the x plus 1. And then that's plus, well, 3 multiplied by x gives me 3x. And 3 multiplied by negative 4 gives me negative 12. So after a bit of tidying, this is what I end up with. 2x plus 3x gives me 5x. And 2 take away 12 gives me minus 10. And denominator, I end up with 6. And that equals 5. Okay, so this is looking a little bit better in the sense it's just one fraction equals some number, but we're still not quite there. So here's the idea. What I'm basically saying here is I'm taking the entirety of 5x take away 10 and I'm dividing it by 6. So what's the opposite of dividing by 6? That's what's making my equation awkward at the moment. It's times by 6, isn't it? So if I times both sides by 6, this is what I end up with. I get 5x minus 10 on the left-hand side because the divide by 6 and the times by 6 have cancelled. And the right-hand side, 6 times 5, that's just 30. And then this is just a really easy equation to solve. So as a general rule of thumb, in order to get rid of fractions, you just multiply through by the denominator and that will get rid of them for you. And then you'll be left with something that's really easy to work with. So, okay, I'd add 10 to both sides. In fact, I'm not going to even bother writing it. I'm just going to write 5x equals 40. Like, I've done that step in my head. I don't need to write down the plus 10 to both sides. And then I'm going to divide both sides by 5, so I should end up with 8. X equals 8. Okay, so hopefully you're really good at solving equations like that by now. So let's have a look at this one. Well, I could, if I wanted to, put it all over the same denominator like I did in the last example, and it would all work. Just be careful, you'll have the negative here, so just watch that. But actually here, this is really straightforward. I am just going to put brackets around the x plus 8 and the x minus 8, just to remind me that they are kind of separate. I'm subtracting those entire two things from each other. But if I want to get rid of the denominators, I can get rid of them in one fell swoop. I can do that by seeing, well, okay, I've got a 5 on this side and a 2 there. So if I multiply through by, I don't know, 10, then that will get rid of everything on the denominator. 5 times 2 makes 10. Okay, so I'm kind of skipping a few steps and doing them in my head. Again, if you want to write them down, go for it. So I'm going to multiply both sides by 10. Well, if I multiply the first fraction by 10, are you happy? 10 divided by 5 is going to give me 2. So I'm going to have to multiply the first thing by 2. Okay, the denominator has gone because I've done 10 divided by 5, which makes 2. And then I'm subtracting, well, let's do the second fraction now. I'm multiplying that by 10. Well, 10 divided by 2 makes 5. So I'm going to take 5 and multiply it by this. Okay. And on the right-hand side, if I multiply by 10, I end up with 40. Okay. So if you're not sure how I get from here to here, do it the way which I did in my first example, and I promise you'll end up at the same point here. Then all I need to do is just expand this out. So 2 multiplied by x plus 8 gives me 2x plus 16. And then be careful here, I've got the entirety of minus 5 and I'm multiplying it by x minus 8. So minus 5 times x gives me minus 5x, and negative 5 times negative 8 gives me positive 40, and that gives me 40 on the right hand side. Collect together like terms now, so 2x minus 5x makes negative 3x, and then 16 plus 40 makes positive 56, and on the right hand side I'm just left with 40 as before. Now I can solve this properly. So plus 56, I'm going to get rid of that by taking away 56. So I end up with negative 3x equals, what's 40 take away 56? It's going to be negative 16. And then I just divide both sides. Well, I'm going to divide both sides first of all by 3. So I'm going to end up with negative x equals negative 16 by 3. Don't worry about the fact it's horrible. Okay, and then I just get rid of the negatives on both sides. Like I just multiply both sides by negative 1. So x must be equal to 16 over 3, if I've done my maths right. But the process is fine. Okay, so now let's have a look at this one. This one's a lot more awkward because I need to get the same denominator. So I can see, in order to get the same denominator, I'm going to have to multiply both. I'm going to multiply the denominators of both fractions together. So I'm going to end up with x plus 3 here. And I'm going to multiply by 2x plus 6. So that's my common denominator right there. Now I'm going to try and combine this together. I'm going to try and speed this up a little bit. So, okay, what have I multiplied the first fraction by in order to end up with an x plus 3, 2x plus 6 on the denominator? I've multiplied it by 2x plus 6. Okay, so I end up with 5 multiplied by 2x plus 6. Okay, and on the second fraction, what have I multiplied by in order to end up with an x plus 3, 2x plus 6 on the denominator? I've multiplied it by x plus 3. So I end up with 2 multiplied by x plus 3. Okay, and that all still equals 4. If you're not sure how I got there, all I've literally done is I've skipped a few steps in my head, and this comes with practice, and hopefully you can see that too. But if you want to do all the steps in between, go for it. Just simply write it as one denominator. You should know how to do that now. Okay, so then when I'm at this stage, what I'm going to do is I'm going to get rid of the fraction. The easiest way of getting rid of the fraction is to multiply both sides by that entire denominator. So, okay, if I multiply the left-hand side by that denominator, I end up with this. Are you happy that the denominator's effectively gone because I've divided by it, but then I multiply it? And on the right-hand side, I end up with this. What have I got? X plus 3, and then a 2x plus 6 right there. Okay, and then here, if I expand the left-hand side and right-hand side out, I'm going to go through this fairly quickly, but if you need to go through it slower and go back to previous videos, go for it. So on the left-hand side, I end up with 10x plus 30 plus 2x plus 6 equals, now I'm going to leave the 4 outside for the time being and just expand those two brackets out. So I end up with x plus 3 times 2x, which makes 2x squared, x times 6, which makes positive 6x, plus 3 times 2x makes 6x, and then I'm going to end up with 3 times 6, which makes 18. Okay, so then I multiply all of this by 4, so I end up with 8x squared plus, well, 6x plus 6x makes 12x, so I'm going to multiply that by 4 as well, which makes 48x. And then 18 times 4, double it again, so 36, 72. Okay, and then I try and simplify this horrible thing. So, okay, how many x have I got on the left-hand side? Collect together those like terms. I end up with 12x. And then I end up with 30 plus 6, which makes 36. Okay, fine. So first things first, I need to get all of the x's on the same side. So I get, well, I'm going to take this on this side. Okay, so let's see what happens there. So I end up with an 8x squared. So on the left-hand side, I end up with 36. On the right-hand side, I get 8x squared. 48x take away 12x is going to give me, what's it going to give me? 36, 26x. And then I just end up with a plus 72 there. Okay. And then I take away 36 from both sides. So I get 0 equals 8x squared plus 26x plus 36. Now, we don't currently know how to solve this quite yet. We will do, but not quite yet. So I'm going to leave it there and look at my quadratics videos if you want to solve that. But essentially, that's how to get to that point there. And then finally, for this question here, I'm just going to try and get the same denominator. So I'm going to get the same denominator by going x minus 1, x minus 2. Okay, still going to be left with 1 on that side. What have I multiplied that first fraction by in order to get that denominator? I've multiplied it by x minus 2. So I end up with 5x, x minus 2. Then I have minus 5x, be careful to keep the minus 5x there, and I've multiplied that one by x minus 1 to get that denominator, okay? So that's pretty much how quickly you should be doing those things, okay? It will get there with practice, right? Okay, and then I multiply both sides by the x minus 1, x minus 2, so 5x, x minus 2, and then minus 5x, so that's a 6x there. My mistake, x minus 1, and then I get x minus 1, x minus 2, and then I expand that out and try and solve that. I'm not going to solve that here, but essentially that's how you would deal with getting rid of the fractions there.